guys, so let us jump straight into this. We're going to just start with some basic examples, excuse me, just to sort of get us back into what we spoke about on Monday, and then we'll sort of amp it up, start looking at more complex questions. So we are being asked to determine the perimeter of the following shapes. Now, just remember, we spoke about this on Monday, but just as a reminder, when we are talking about a circle's perimeter is actually called the circumference. Circumference. So it means exactly the same thing as a perimeter. It's just specific for a circle. Right, and guys, remember your perimeter is the length or the distance around your shape. All right, and obviously now it's gone all wonky, but we'll just fix that. So that is the circumference of my circle or perimeter. Now on Monday, I gave you a formula that you need to use in order to work out the circumference. I'm going to write it down again for you, just in case for whatever reason you have forgotten or weren't here, that anytime we want to work out the circumference of the circle, we need to do the following. Now guys, what's really important is that there's actually two formulas to work out the circumference. They're basically the same thing. One just uses diameter, the other radius. But we spoke about the fact that your diameter is double your radius, hence why we can have these two formulas. So either we use 2 times pi times r, which you could just write as 2 pi r, or we say our circumference is equal to pi times diameter, or you can just write this as pi d. Right, so again, 2 times r gives us a diameter, hence why it's basically the same formula, and you can use either one. I know a teacher is ever going to tell you have to use one or the other. I'm certainly not going to tell you which one you have to use. It is completely up to you. My advice is pick one and stick with it. So for me, I always use 2 pi r. That's just the formula I go to, but you don't have to use that formula. Alrighty, so if we have a look at our circle, quickly on the chat for me, I don't actually know how to put this into words, what length is the 120 millimeters? What do we call that length in a circle? Nice, grade 8s. Very, very nicely done. All right, so exactly, this is my diameter. I know it is the diameter because the arrows are showing that I'm going from one end of my circumference to the other, passing through that center point. So I know it's my diameter. We know that your diameter is double your radius. So if you say 2 times your radius, you get your diameter. The other way to look at it is that your radius is half of your diameter, right? Same thing, depends what you're looking for. So I'm going to show you how to use both of these formulas. Again, it is up to you which one you want to use. Personally, I prefer 2 pi r, but it genuinely makes no difference. You will get the same answer. Okay, so if we do use the 2 pi r formula, we know that our circumference, which I'm just going to abbreviate to circum, is equal to 2 times pi times my radius. Now remember, we just said that the radius is half the diameter. So in this case, my radius would be equal to 120 millimeters divided by 2. And so my radius here is 60 millimeters. So I would have 2 times pi times 60. Right, and on the chat, very nicely done. Okay, so guys, once we've got that, remember you have a pi button on your calculator. That's what we use. We don't have to do anything fancy. If for whatever reason your calculator doesn't have a pi button, pi we use is 3,142. So that's what you can type in. Sometimes we tell you to use 3,142, but otherwise you just use the button on your calculator. So 2 times pi times 60. You type that into your calculator. You push answer. Now your calculator will always give you the answer in pi. So it will tell you this is 120 pi millimeters. But remember we spoke about the fact that that means nothing to me. I have no idea what that means. So what we do is we push that SD button on our calculator, and our calculator converts it to a decimal. So this circumference is 376,99 millimeters. Generally, we always round off to 2 decimal places, and don't forget your units. Remember, there are units to your answer. You need to have units there. Okay, so that's if we use Formula 1. If you don't want to use Formula 1, which again is absolutely fine, and you would rather use the circumference is equal to pi times diameter, you get exactly the same answer. So pi times my diameter, which we know is 120, because that's what we were given, we get 120 pi millimeters, which is exactly the same thing that I got in the other method. So it's exactly the same. And when we convert that, 376,99 millimeters. So again, grade 8, I really, it makes no difference which formula you choose to use. It is your choice. Like I said, I personally would pick one and stick with it, just so that you're not learning more formulas or more rules than necessary. But it is entirely up to you. My preference, 2 pi r, but you do what you want to do. The reason I'm saying you can pick which one is because you can always convert from a diameter to a radius, like we did here, or from a radius to a diameter. So either one is exactly the same thing. All right, guys, so let's take our screenshots of this, and then, whoops, we're going to have a look at question B. Alrighty, so if we have a look at question B, I don't know why I said take a screenshot because it's still on the screen, but it doesn't matter. We now want, once again, the perimeter. Circumference is only for a triangle. So my perimeter is the length of whatever BC is, which in this case is the 12 millimeters, plus the length of AB, which is 5 millimeters, plus the length of AC. Now, we don't know what AC is, but we know that we could go and work that out. So guys, how would you work out the length of AC? What method would you use? Nice, guys. Awesome. Good. Okay, exactly. We would use Pythagoras. Right, so what I want you to do, and again, it's because we've done Pythagoras quite a bit, I want you to go and work out the length of AC for me. If you're feeling super comfortable and you feel like you can go ahead and then work out the perimeter, you can do that. But let's work out the length of AC to start off with. Right, remember when you are working on Pythagoras, you need to give Pythagoras as a reason. So just remember your reason there. But let's work out the length of AC. Nice, guys. Keep them coming. Good. Okay, so if we do AC, remember, first thing we always do with Pythagoras is we identify our hypotenuse, which is opposite the right angle. And so here we can see that AC is the hypotenuse. So AC squared, hypotenuse squared, is equal to the sum of my two other sides squared. So 5 squared plus 12 squared. And you can give Pythag as your reason. You know, guys, you could just do that on your calculator. There's no need to do it separately. So if you did, you would get that AC squared is equal to 169. If you do those calculations separately, that's also absolutely fine. We know we need to square root both sides because we do not want AC squared. We want AC, so we need to get rid of that square. And from there, we get that AC is equal to 13 millimeters, as you guys have put there on the chat, right? So now we know that's 13 millimeters. We now need to work out our perimeter. Now, the perimeter is what I've highlighted. And because I now know all three sides of my triangle, I just add them. So the 13 plus the 12 plus the 5. 13 plus 12 gives me 25, plus 5 gives me 30 millimeters. Again, please remember your units. They are there for a reason. We have to put them in. And so often with triangles and perimeter questions, we will give you something like this, where we give you a right angle triangle and we expect you to first do Pythagoras and then only work out your perimeter. It's one of the ways in which we test Pythagoras. And so it's really important that you guys remember your Pythagoras, do it, and then only find your perimeter. Right, so I'll hang 10 there. If you need to take screenshots, let's do that. If anyone has any questions at this point, we can raise our hands, but this is a recap of Monday's lesson, so it's nothing new. And remember, guys, if you miss a lesson, it is your responsibility to catch it up and watch the videos. But if there's any questions, we can raise our hands, or remember, you can always put them on the chat as I'm going along. Right, this question has been asked before, Semtanda, but the question is, guys, what if you don't put your units? At some point, you will be penalized. So let's say if throughout your entire test, you don't put your units, you will be penalized at 1 mark somewhere. You will not be penalized for every single time you forget your units, but you will lose a mark. All right. Amange?
Hi, ma'am.
Hi.
I just want to ask for A, the circle, you said 2 times pi times 60 in brackets, since 120 divided by 2 is 60. And then why did you like put 120 again? Like under the other under 2 times pi times 60.
So if you type 2 times pi times 60 on your calculator, the answer it gives you is 120
Yes.
pi. So that's why I've written 120 pi. The 120 comes from the 2 times 60.
Okay.
Okay. And guys, what Amange has just pointed out there is the relationship between diameter and radius. 2 times the radius, 2 times 60 gives us that 120 of the diameter. So that's why we have this formula, or these two formulae that work. Alrighty. Good, guys. Okay, so this is now where things start to get fun. We will start to expect you to work with shapes that are what we call composite shapes or complex shapes. Basically, it's not a square, rectangle, triangle, circle. You can't just coin a formula and go with it. It's not going to work. So what we need to do is we need to be able to essentially break a shape up into shapes that we are comfortable with. Right, so let's read this question. I'm just going to move it down a touch. The question says to us, and we need to read it carefully because I've given you information here that's useful. The perimeter of the shape below is 30 centimeters. Determine the value of x. Alrighty, so if we go to our shape, I'm telling you that if you say x plus the 3 centimeters down the side, plus the 5 centimeters of that like slanted length, plus the 10 centimeters, plus the 6 centimeters up the left-hand side, you will get 30 centimeters. Okay, I've told you what the perimeter is. And so what we need to do is we almost need to work backwards to figure out what our perimeter, what our x value is. Now guys, again, lots of different ways that you can do this. But like I said to you on Monday, try and start using algebraic methods. And when I say algebraic methods, I mean try and set up an equation to solve for x. Later on in maths, that is what we expect you to do. So you might as well start getting into the habit now. So what I mean by that is if we say x plus 3 plus 5 plus 10 plus 6, we must get the 30 centimeters. Now we can add our like terms. 3 plus 5 is 8, plus 10 is 18, plus 6 is 24. Whoops. And using my inverse operations, I will subtract 24 on both sides in order to solve for x. And so x, as all of you are beautifully putting there on the chat, is 6 centimeters. Okay, so we need to be able to work with these slightly more complex shapes. We need to be able to work backwards from a perimeter to a given dimension. And you're going to see this is sort of what we're going to start doing today. So, oh guys, sorry, I've got a frog in my throat. So these are the types of shapes that you need to start being comfortable with. In grade 9, we deal a lot with these, and in Maths Lit, we deal a lot with these. Not so much in maths. Maths, we focus a little bit more on 3D shapes, which you deal with more in grade 9. But the basics of what we're learning here are going to be applied to those 3D shapes. So it's really, really important, as I keep saying, that we get these foundations right. I think Seth is laughing at my frog in my throat. Okay, guys, so let's take our screenshots. Let's, if you've got any questions, let me know. Otherwise, we'll take a little brain break, and then we're going to carry on with some more examples. Okay, no questions. Nice, grade 8s. Alrighty. Joke of the day, maths, what is brain break of the day? I said maths 24 of the day. Losing my mind. Okay, guys, you know how this works. What we want to do is we want to find the value of this last equation down at the bottom based on the information that we've been given here. So let's give it a try. First person to get it right, we will shout out your name in the chat once I see your answer, and then you will explain it for us. The first one, actually, if you were listening to the Maths 24, the Maths 24 methods is going to be helpful for the first one. But let's see. And guys, also remember to look out if there's 2 of the bird or 1 of the bird, so that you're not making silly mistakes like I often do, and don't use my eyeballs. Just want to close this blind behind me because it's glaring. Nice, grade 8s. Well done. I've already seen some right answers. I just want to make sure I haven't missed anyone. Get the first person to get it. Connie, well done. If you want to raise your hand to explain to us how you got it, that would be amazing.
Come on, Connie. There we go.
Nice.
Hello, ma'am.
Hi.
So for the first one, I said I divided 24 by 3, and I found out that the birds are 8.
Nice.
And for the second one, I divided 40 by 8, and I got 5. So the chickens are equal to 5.
Okay.
For the third one, I times 5. I divided 5 by 40 and minus 5, which gave me, no, not minus 5. I divided, no, I found out that the penguin is 7.
Nice.
So the two parrots times the penguin plus the 2 chickens is 122.
Perfect. And guys, I really hope you heard there how Connie distinguished the fact that we have to do the times first, right? BODMAS, you have to do multiplication first. You got no choice in the matter. Amazing. Well done, Connie. Thank you so much for explaining for us. Okay, guys. So exactly. And then in case it wasn't clear, although I'm sure it was, and because Connie said the 2 parrots and the 2 chickens, we have to double those values. So 1 parrot is 8, 2 parrots 16, 1 chicken 5, 2 chickens 10. Right, very, very nice. Well done, guys. Okay, if you still need a little stretch or something, please feel free to do it. I feel like you guys got that brain break so quickly, but I'm going to move on to our next example. And like I say, guys, it's definitely getting slightly more complex, and so we need to be ready for that. Okay, right, so this is what I mean by it's getting more complex. We are wanting to work out the perimeter of the shape, but now it's not just a rectangle or a square. It's like a weird mixture of all of these things. So what I always like to do is I like to figure out what lengths do I have. Okay, so I've got this 15,8 centimeters. And guys, what's really important is that because of these right angles that have been indicated to me on the shape, technically that means that if I were to extend this bottom length down here all the way to the edge where it meets up with the side, that too would be 15,8 centimeters. I obviously can't draw a straight dotted line, but it would be 15,8 centimeters. That's going to be quite helpful to us in a second or two, so I'm just going to write that down for now, but we'll get there. Right, the next length that I know for sure that I have is this 14,7 length. Once again, not quite capable of drawing a straight line, but we move. Right, this 14,7. Again, because of the right angles, technically what I'm working with is a rectangle that just has pieces cut out. And so that would mean that if I extended the 7,2 centimeters all the way down to the bottom, I would once again have an entire length of 14,7 centimeters. So again, piece of information that's quite helpful for me to know. So this entire length, I don't know what that was. It was trying to be a bracket. It didn't. This entire length here would be 14,7 centimeters. Right, now all of this is helpful to me because remember my goal here is to work out the perimeter of the shape. Hello. Okay, so perimeter, I need to essentially go along this yellow line and I need to work out all of the lengths to add them together. Right, so once I know what I have, I'm going to go now and I'm going to figure out what do I need to work out. So I'm happy that I've got this 15,8, I've got the 14,7. I do not know what this length down here at the bottom is. Okay, that's something I need to work out. However, if you take that length and you add this length and you add that length, do you not just get the whole 15,8 that we spoke about? So we do not need to work out these individual lengths for ourselves because we know if we actually just place them all together, I would get 15,8. So all three of those together, I get 15,8. The next lengths that I would need to work out are then like up the side. So this vertical length, and I know that this is 7,2. But again, if I took all of those vertical lengths and I stacked them all up, I would actually just get the whole 14,7. So it's really important that we do look at shapes like this with an understanding of how side lengths or how dimensions are made up, because I actually need to do no working out of missing lengths here. I actually have all of the information that I need. So in order for me to then go and find my perimeter, all I need to do here is I need to say 15,8 at the top plus the 14,7 down the right-hand side plus the total 15,8 that those bottom segments make up plus the 14,7 that the side segments make up. And all of that added together will give me my perimeter. Okay, so that is a total of 61 centimeters. And those of you on the chat, well done on getting that. Right, so guys, the trick with these composite complex shapes is, like I say, look at what you have, look at what you don't have, and look at how you can work out what you need. Sometimes there will be more calculation required, but in this case, I didn't have to do anything. I needed to look critically at my shape, get my values, and then I could easily work out my perimeter. Alrighty, so if there's any questions, now's the time to raise your hand and ask. Otherwise, let's take our screenshots and then we're going to have a look at another one. Yes, remember today we are doing perimeter. I said earlier that we will only stop area on Monday. Lindo?
Hi, ma'am.
Hi.
Ma'am, can I ask for an 7.2 centimeters? Why didn't you make it 14.7 centimeters while when you put down that straight line, it's 14.7 centimeters?
Yeah, so the 7,2 is only this top bit here. If I then add together this vertical line, so add it there and then add together that vertical segment, it all adds up to the 14,7. That's why I added 14,7 twice.
Oh.
Okay.
Thank you, ma'am.
Sure. Tandawake, I have just answered that question, so I hope you heard. Nelson, I don't know why we're spamming the chat. Let's not do that, please. Chloe? Chloe, there should be a pop-up to unmute yourself. Chloe, are you there? Oh, Chloe, your audio is cutting in and out. Try and type your question in the chat for me or send me a message because I can't actually hear what it is that you're saying, unfortunately. Chantal?
Afternoon, ma'am.
Afternoon, how are you?
I'm fine, ma'am. Ma'am, can I please ask, ma'am, if you don't put the centimeter, ma'am, is the answer wrong, ma'am, or is it correct?
Okay, so grade 8, I want everyone to listen right now because this question has been asked quite a few times. So I'm going to answer it again, but then I'm not going to answer it going forward. If you don't put the units, at some point in your measurement, you will lose a mark. You will not lose a mark for every answer that you forget the units, but you will lose a mark somewhere, right? So essentially what that means is if you have 5 perimeter questions and you forget your units in all 5, we will only take a mark off in one of those questions. We will then let it slide for the others. But yes, at some point you will lose a mark. Alrighty. Tatenda?
Hello, ma'am. I just wanted to make sure. I just wanted to make sure that the reason why I'm not adding 7,2 centimeters is because the 7,2 centimeters is outside. It's inside, not outside.
Okay, so grade 8, again, I want everyone to listen because this has been asked in a couple different ways, but it is essentially the same question. We are adding the 7,2, but just not as 7,2. So remember what I said to you was, The 7,2 is sort of this section on my rectangle. We then spoke about the fact that if we take this vertical length and this vertical length, and if we stack them all up with the 7,2, 7,2 plus whatever that length is, will in total become 14,7. So I do not need to add the 7,2 by itself because it's actually incorporated in my 14,7 already. Okay. Good. Right, so guys, I hope you all listen to that, and I hope these hands are not a repeat of the same question. Okay, your name is not Tab7 Light, but that is the username I have here. There we go.
Hello, ma'am.
Hi, what is your name?
My name is Tab7 Light.
Ready?
No, ma'am, it's Tabiso, ma'am.
Okay. Right. So
Ma'am, I wanted to ask, what if, don't we put centimeters squared?
So remember, it's perimeter. It's not area.
Oh, yeah, ma'am. Sorry, ma'am.
Okay.
Yeah.
No.
Silly mistake.
But guys, exactly. Area, we will put centimeters squared. Okay. Right, guys, any other questions, please put them on the chat for me. I'm moving on. Nelson, if you spam the chat again, I am going to ask that you are removed. Please don't do that. We're trying to focus. Okay, Chloe, I see you said your audio is fixed. Let's see.
Oh, ma'am, can you hear me
There
fine
we go.
now?
Yes.
Ma'am, I wanted to ask, ma'am, when we plus all the blocks together, should we find out the measurements for the open spaces and divide it because it's not a full square? I don't know if
Okay,
someone
so-
knows that question is glitching, but yeah.
Yeah, so like I said, we don't have to. I'm just going to take all of the scribble off because it's actually just chaotic. The reason that we don't have to go and work out all of that stuff is because if you take this length and you sort of slide it over and you put it there, and you take this length and you slide it over and you put it there, it forms, let's do that a bit better, it actually forms the rest of my rectangle. In the same way that if I take this horizontal length and slide it down, and this horizontal length and slide it down, it forms my rectangle. So just because I've got this like zigzag thing in, doesn't mean it's not a rectangle. I've just like indented those lengths. It's still just a rectangle. So I don't need to work out those lengths because I know the dimensions of my rectangle.
Ma'am, now when do we know when we have to like minus the lengths?
Okay, so that's going to be more when you have again, it depends on what information we've given you. It would be more a case of like something like an H sort of shape where it like indents in and like we can't necessarily work out certain lengths, or potentially something where there's like a triangular side and then you would have to maybe use Pythagoras to work out the missing slant length.
Yes, I see. Thank you, ma'am.
Okay. Good, guys. Good questions. Alrighty, let's have a look at this next one. And this is kind of what Chloe was asking here because we have some lengths that we do know, we have some lengths that we don't know. Sometimes we will have to subtract, and again, it comes down to what diagram or what information I give you. Right, but let's have a look. So again, the question was determine the perimeter. So the perimeter is along JK down to KL, or down KL rather. It's really going to annoy me if I can't draw a straight line. Okay, all the way along from L to H, and then from H to J. So that is the perimeter that I'm looking for. First thing, what am I looking for? Second thing is, which bits of information do I know? Right, so I know the 6 meters, I know the 5 meters. When it comes to this base, guys, we only know the measurement from M to L. That is what the 10 meters is. I have no idea what this length from H to M is. Moving along, I have the 4 meters. So the only missing length that I have there is that HM length. Now, if you have a look at the diagram that you have been given, we can easily go and work that out, because what we should see we have here is a right-angled triangle. So if I sort of remove the right-angled triangle, exactly as Sinyane said, we can find HM using Pythagoras. Right, so here's that triangle that we have. You don't have to add all of these labels like I'm doing. I just want you to see that I've taken a portion out and we're going to be able to use it. HM is what I don't know. I know this is 3 meters. I know this is 4 meters. There's my right angle. I can use Pythagoras. Right, so grade 8s, I want you to, whoopsie daisies. I want you to please use Pythagoras for me and work out the missing length HM. And then if you can go a step further, determine the perimeter of this trapezium. Okay, so let's give it a try. We're using Pythagoras to work out that missing little bit at the bottom, and then we want to work out the perimeter, so what I've highlighted in yellow there. Now again, grade 8s, like I said, like this is often where we will test Pythagoras, okay? Within the context of a perimeter type question. I will tell you now, guys, HM is not 5 meters. It is not 5 meters. Guys, remember, your hypotenuse has to be the longest length, right? Your hypotenuse is HJ, so HM cannot be bigger than 4. We need to keep all of this information that I've given you at the back of our heads. I'm going to say it again. HM cannot be bigger than 4, and HM is not 5. I think some of us need to go and revise Pythagoras again, grade 8s. You'll see now in a second, but remember all of our Pythagoras videos are up. I strongly recommend you go and watch them again. Right, answer, please round off to 2 decimal places. You would only round off otherwise if we tell you, otherwise always 2 decimal places. Don't give up. Keep trying. Excuse me. I'm liking these answers a bit better. Okay, grade 8s, let's have a look, because there is a variety of stuff going on here. Right, so remember we've identified our hypotenuse, it's opposite the right angle. So hypotenuse squared, 4 squared, is equal to the sum of the square of my 2 other sides. So HM squared, which is what I want to work out, plus the 3 squared. And this is all because of good old Pythagoras. Alrighty. Once we've got that, we've got 16 is equal to HM squared plus 9. Inverse operations, I need to subtract 9 on both sides in order to get the HM squared alone. And 16 minus 9 is 7. Now remember grade 8s, we're looking for HM, not HM squared. So we need to square root both sides in order to get rid of the square. And so what we end up with is that HM is equal to 2,6,6,4,5,7,5,1,3,1,1 meters. Okay, now it's a whole long decimal. Technically, grade 8, this is not your final answer, and so you should be working with that whole long decimal until your final answer. So Sean, please just listen. We do not round off until our final answer. I've said this before, I'm saying it again. We do not round off until our final answer. So your calculator has got that answer already stored on it. So now when you do the perimeter, you literally just have to push the answer button down there, answer, and it will automatically use that whole long decimal in your calculation. So now when we want to determine our perimeter, you can just say P, you don't have to write perimeter each time. We've got this 2,64, and then I'm just going to use a dot, dot, dot to show that it keeps going, plus my 4 meters, plus the 6 meters at the top, plus the 5 meters down the side, plus the 10 meters down at the bottom. I've already included HM right at the start. Okay, so I add all of that up, and we get that our perimeter is 27,6457 blah, blah, blah meters. Now we can round off because this is my final answer. And so we get 27,65 meters. Right, so grade 8, where I think maybe we had a bit of an oopsie is we forgot in the Pythagoras that we needed to do that subtraction. Remember, we made many a note saying that when we have the hypotenuse and we're looking for one of the other sides, we subtract. So please just remember that. And like I said, go back to the Pythagoras videos. Go back to those videos and watch them so that you know how to work with Pythagoras. Okay, there's a question of, please show me how you got the 2,64 on the calculator. All right, so 16 minus 9, whoopsie daisies. Okay, and just in case we don't know where I am, I'm here at that working out. So 16 minus 9 is 7. That gives us HM squared. I don't want HM squared, I want HM. So I need to square root that answer. So I need to square root 7. And the square root of 7, when I convert that to a decimal, no, push the wrong button, gives me 2,645751311. So when I square root 7, that is where I'm getting that decimal from. And I have to square root the 7 because I want HM, not HM squared. All right, so that's where we're getting that whole long decimal from, grade 8. Ow. So just bear that in mind. If you also wanted to, because it's not your final answer, you could actually just work with square root 7 in your working out and just type square root 7. Like, there's nothing wrong with that. So Siamtanda, in this case, you will get the same answer because there was only one decimal value. Where it becomes a bit trickier is where there's multiple decimals that have been rounded off. And then when you start to add those rounded off values, then things start to change a little bit in the decimal. Like, it's really not the end of the world, but for accuracy, you should only ever round off your final answer. Okay, so grade 8, let's take our screenshots.